Hi folks, we're going to take a look at page 470, number 3b. So they give us this figure here and they want us to find the perimeter and the area. So it looks like the perimeter is going to be the easier one, so I'm going to start with that. So the perimeter, well, we have these two sides of the triangle that make up the outside of the figure. So we have 10 plus 10. And the other thing that I have is this semicircle. Okay, so I know that the perimeter of a full circle is equal to 2 pi r, so 2 times pi times. Now here I have to be careful because what they've given me is the diameter, so the radius would just be equal to 4. Okay, 2 times pi times 4. But since I'm only taking half the circle, I'm going to divide that by 2. Okay, so this is the expression that's going to give me the perimeter, and before calculating I might as well simplify. See that this 2 in the numerator reduces with the 2 in the denominator. That's because I have all multiplications and divisions here. Okay, so now I'm just going to take this and put it into my calculator. Okay, so I've got 10 plus pi times 4, which is the radius. Okay, and I don't need to worry about bedmass because the calculator does that for me. Okay, so here we have 32.6. They actually asked me to find it to the nearest tenth, so that's why I'm going to take 32.6. Okay, so here we have 32.6 centimeters since it's perimeter, so it's a length measurement. Okay, now the area is a little more difficult because finding the area of the semicircle is easy, but finding the area of the triangle is going to take some work because I don't know the height of the triangle. But the reason why this is easy enough to do is because it's an isosceles triangle. So I know that the height is just going to split the base in half. Okay, and again, that's only because it's an isosceles triangle that I can assume that. Okay, so what I need to do is I need to find the height of this triangle, so I'm going to do that before I find the area. So here I have a right angle triangle, so I can use Pythagoras. So I've got h squared plus 4 squared is equal to the longness side, the hypotenuse squared. Okay, I should have put 10 squared, but there's 100. And so h squared is equal to 100. Bring that to the other side, minus 16. And I take the square root of both sides to isolate h. So 100 minus 16 is 84. So this is the square root of 84. Okay. Now you're going to see me do this quite a bit, as I'm going to try to avoid estimating numbers until I get to the very end. However, if you feel more comfortable getting an estimate for the square root of 84 and then inputting it in your equation, that's fine, but I'm going to do it without making the estimate yet. Okay, so let's calculate the area now. Okay, so the area is the area of the semicircle. So the area of a circle is pi times r squared, so pi times 4 squared, but I'm going to divide that by 2 because I only need half a circle. Okay, and then I'm going to take the area of this triangle, which is base times height divided by 2. So the base of the triangle is 8 times the height, which I just found is square root of 84, okay, and divided by 2. Okay, and now again I'm going to try to just put this whole thing into my calculator. Okay, so let's see how I do that. So first I'm going to use my pi button. I have to have a pi button, so pi times 4 squared. Okay, and since these are all multiplications and divisions, I don't need brackets here. I'm just dividing the 2 in the denominator. So there you go. And I'm going to press the equal sign just so that I don't have to have too much stuff on my screen. Okay, and I'm going to add the area of the triangle. So 8 times square root of 84. Close that off. Okay, and divided by 2. Okay, and I get my final answer here of 61.8. Okay, so that's equal to 61.8. And since this is area now, this is going to be centimeters squared. Okay, so a couple of things here. First of all, make sure you have all the required dimensions. Make sure when they give you the diameter to a circle, you need the radius that you divided by 2. Okay, make sure you're using the correct height. In this case here, we didn't have the height of the triangle. We needed to calculate it. Okay, and when you're actually using your calculator, see how comfortable you are. If you're comfortable calculating everything in one step, that's better. You'll get a more accurate answer. But if you need to do it in small stages, that works also. Okay, that's it for this one.